This is going to be chapter 4.3 to 4.4, and we're going to be talking about logarithms. So logarithmic functions are basically very similar to exponential functions. So we've talked about an exponential function that kind of looks like this, 2 to the power of x. And now what we want to do is talk about these logarithm functions and how exactly they work. So one of the things to kind of that we've been wanting to know about functions in general is, do they have an inverse? Do they have an inverse? And because we know what 2 to the x looks like, 2 to the x looks like this. Okay? So we can clearly see that this 2 to the x is 1 to 1. And what it means to be 1 to 1 is that it posits the horizontal line test. So we know that an inverse must exist. Okay? So one way that we can try to figure out is, well, let's replace the f of x with the y. And we're going to swap the x's and the y's. Okay? Just like that. But notice that when we swap them, well, how do you solve some of this? Okay? So it's going to be really difficult to figure out what that is. So instead, what we want to be able to do is try to figure out or come up with a new type of function that will explain this scenario. So what power should I raise y to get x? Okay, that's basically what I want. Y should be the power that I raise to get x. That's basically what I want to figure out. And what we're going to write is the following thing. So y is equal to log base a of x. Okay, so this is a new notation that we're going to be using, because the top part was not possible, so we have to come up with a new thing. Log here is just it's Greek for number. Okay, so we're just thinking of what number should I raise what number should I raise to get an x. So here is just basically saying the exponent to which a must be raised to give x. That's basically what log means. Okay, so it's just basically give me the exponent that I should raise this to get an x. So if I wanted to write this guy in terms of logarithmic form, then it'll be y is equal to, we're going to write log first, then the base, and then x. Okay, so the way that we have it here, this 2 on the bottom is basically the base. X here is the argument. Okay, basically think about it as the answer. Y here is the power in which I raise that number. Okay, so that's basically what it is. So let's start working with logs and trying to wrap ourselves around these. Try not to use your calculator. Log is in there, but try not to. So let's just try to figure out if we can try to do this mentally. So evaluate without a calculator. Okay, so let's say you wanted to figure out what log of 2/4 is. Log base 2 of 4. So remember, this means what power, so think of log saying, what power should I raise 2 to get a 4? Well, that's just 2, right? So this should be a 2, because 2 squared is going to give me a 4. Okay, so let's think of this one. Okay, so what do you think this one would be? Okay, so this one should be a 3, because what power should I raise 3 to get 27? 3, because 3 cubed gives me 27. Okay. Let's do this tricky one. So what power should I raise 16 to get a 4? Okay, well, nothing, right? Well, actually there is. Think of the rational exponents. So we know that the square root of 16 is 4, so that means the square root of 16 is just 16 to the 1/2. So this guy is just equal to 1/2. Okay, because 16 to the 1/2 power is going to be equal to 4. Okay. This one shouldn't be too bad. What should I raise 10 to get 100? That's just going to be 2. Okay. So let me give you a couple of properties of logs. And later on, we'll do more complicated properties. But these are just some of the basics. Whenever you have the log a of 1, this guy, regardless of whatever a is always going to be 0. And that makes sense because that's, how can I get, what should I raise a number to get 1? Well, 0, because a to the 0 power is always equal to 1. Okay? So that's one of the log properties. Another one is that log a of a is equal to 1, because the only way that I can get the same number is if it's just 1. If you have log base a of a to the x, that's equal to x. And that makes sense because a to the x equals a to the x. And then a log of ax is equal to x. Okay? So here's a couple of things. All right. Other things that we can kind of think about is usually these are what we call common logs. So typically whenever we want to write the log base 10 of something, we don't write the 10, we just write log of x. So if we don't have a 10 on the bottom, it's just, we're just assuming that it's just base 10. Okay, so if there's no number on the on the bottom of the log, then we're just going to assume that it's going to be base 10. Whenever you have log base e, we don't write log base e, we write ln of x. Okay, and ln, this ln, we call it natural log. Just how we have natural e, this is what we call natural log. So ln of x is the same thing as natural log. Okay? So one of the things that we want to be able to do is be able to convert exponential to logarithmic. Okay? So trying to convert exponential to log. Okay? And vice versa. Okay? So if you have y is equal to b to the x, okay? So this is basically the exponential. And you want to convert it to a log, then basically what you're going to do, you're going to first start off by writing the x first, then writing log of b of y, okay? So basically what you're doing is that these x's and this y is basically switching places, okay? And then the b is getting really, really small, okay? And then you're just writing the log right next to it, okay? So another way that you can write it is that you're switching the places, so you're going to write log first. The b gets really, really small, and then you switch the x and the y. So here's another way that you can do it. Okay, so you write the log first, make the b, who's really, really big, now we're going to make it really small, and now the y and the x change. Okay, so let's do an example on how to convert it. So convert exponential to log. Okay, so let's say you had y is equal to 3 to the x. So how would you change this to a logarithm? Well, the first thing that you can do is you can write log, okay? What's going to happen to the 3? The 3 is going to get really, really small, and then I'm going to change this x to a y. and then the other one's going to be just an x. Okay, you could have also written x is equal to log base 3 of y. Okay, what about this guy? If you had c is equal to d to the t, so what would this be? So first we're going to start off by writing log. The d in this case is the base, so it's going to get really, really small. And then I'm going to get rid of this t, write a c, and then the t is going to be on the outside. Okay, so that's how you would write it. How would you write this guy? Okay, or maybe let me write it as e to the x equals 3. Maybe that might be a little easier for you. E to the x equals 3. Well, the first thing that you want to do is we're going to write log. Remember, the base, which is e, is going to get really, really small. And then the x and the 3 are going to switch places. So you're going to have a 3, and then you're going to have an x here. Now, remember, what is log base of e? Log base of e is just ln. So we're going to write ln of 3 is equal to x. So that's what the answer is going to be. Okay. Oops. Okay, what about this guy? Right, we're going to start off by writing log, make the 10 really, really small, and then switch the 2 and the 100. Okay, so remember log base 10 is just, all we're going to do is just, as a common log, we're going to write log of 100 is equal to 2. So that is understood to be log base 10. Okay, so converting from exponential to log is pretty easy. Now let's do log to exponential. Okay, so now if I give you a logarithm, log base a of b equals x, something like that. The way that I like to do it is that I like to start off with the base. So I just like to circle the base first, and I like to circle around. So basically it goes a to the x equals b. So it's kind of circling around that way. Okay, so it's going to be a to the x equals b. All right, so if you follow this arrow, you will never mess it up. Now the only thing that you have to remember about this is that this will work only if the log is first. Okay, so let's say we want to convert to exponential. Okay, so part A, we're going to have log base 3 of x equals y. Okay, so what you want to do is you want to start off with a 3 and circle around. So it's going to be 3 to the y equals x. And that's going to be my solution. Okay, so let's try this one. So let's say you had ln of 3 is equal to b. Okay, so notice here the base is ln, so you have ln, so you have an e in there, and you're just going to circle around. So it's going to be e to the b is equal to 3, and that's going to be my final answer. Okay, and let's just do one more. Okay, so we're going to take this 9, circle it around. So you're going to get 9 to the t is equal to y. Okay, so not too bad. Just make sure that you remember these rules. This will be really useful when we start doing solving equations with logs and exponentials. So that's it for this one.